Today's lesson is on Cramer's rule. Now before you freak out when you're looking at all these and like, oh my goodness, what are all those A's and B's and C's and D's and E's and F's and NX's and NY's, don't worry. This is just to help you set it up if you want to look at an example. But if you watch the first example, you'll realize that Cramer's rule is actually pretty easy to do. You just need to set it up. Now I'll take you through one step by step, and we'll see what happens first before you worry about all this. You can pause the video, copy it all down, and then you can see how it applies, but it's only to help you. I am not going to make you memorize all of that. Okay, so what we're going to do is we're going to start finding determinants. Now to take a determinant, it's a real easy thing. You just multiply twice and subtract. I'll show you how to do that. The most important part about Cramer's rule is setting up the determinants correctly. So to do it, we need a denominator, and the denominator is going to be just the leading coefficients of our system. So we have a 2, 7, -3, 4, and that's going to be called D for the denominator. And then we need to get the numerator for x. To find the numerator for x, we replace the x column with our constants that we find here. Okay, and then we just write 7 and 4 for our y's. That hasn't changed. And then we have to set up our last one, which is our numerator for y. And to do that, we're going to leave our x's alone this time, but this time we're going to replace the y column with our constants 10 and 3. Okay, so as you can see, we are about to find some determinants. Now I know you can do a determinant with your calculator, but with Cramer's rule that would be pretty annoying because it takes a little bit of time to type all these matrices into a calculator. Watch. All you have to do is start up here, multiply that way, 2 times 4, and we get 8 minus, and you swoop back this way almost like a fish. 7 times a -3 is a -21. So 8 minus a -21 is 29. That is the determinant. That's all you have to do. Multiply this way, subtract by multiplying that way. So for this guy, nx, we get 10 times 4, which is 40, minus, and then we swoop back this way, 7 times 3 is 21, and we get 19. We do it one more time, and then we get 2 times 3, minus a -30. So we have 6 minus a -30, which is 36. Now, our final answer to this system is, all we have to do is write our answer like this. The numerator of x over the denominator, comma, the numerator of y over the denominator. And so we go back over here, and x is 19. So our answer is 19 over d, 29, comma, and y, which is 36, over d, which is 29. That is the solution to our system. How would you have liked to solve that system by hand? And you've now figured out why determinants is wonderful. We don't have to work with fractions. The only reason some of the some of the systems you've solved so far work out nice is because we make it that way. Not every system is going to work out with pretty little numbers. You can have systems that look like this. You can have systems that their answers are -107 over some crazy number, 139, or all over the place. We just make them pretty when we do it by hand. When you use Cramer's rule, it'll solve any system, no matter how ugly the answer will be, in just a few minutes by just working with some fractions. Okay, so what I would like you to do is pause the video really quick and try to set up the 3 determinants for this next example. Just set it up, then press play to make sure we have the correct determinants before you start solving. Okay, quick pause, and let's see if you got what I have first. You should have 1, 3, -2, -6 for your denominator, or just the coefficients of x and y. And x we replace with 10 and -20, and y we replace the y with 10 and -20. And now we find our determinants again. So we have a -6 minus a -6, retro, denominator of 0. Don't stop. Keep going. So then we're going to go this way. We're going to get a negative 60 minus a negative 60, and we have another 0. And then this way we're going to get negative 20, and we're going to have minus another negative 20. So you can see we get 0, 0, 0. When you are using Cramer's rule and all three end up being 0, your answer is going to be infinite solutions. Okay, because I know you can't divide by 0, but 0 divided by 0 technically doesn't even exist. You can't divide nothing by nothing, so it doesn't really work. So that's how you get infinite solutions. Now this last example, obviously, I'm going to have another little trick up my sleeve. So try to set it up and solve by determinants this last example in the notes. Go for it. So here's our setup. Determinant, 4 times 2 is 8, minus 1 times 8 is 8. Uh-oh, here's a 0. Keep going. 8 times 2 is 16, minus 12, we get 4. And 4 times 12 is 48, minus 64, which is negative 16. So, now you've got to think for a second. We have 4 divided by 0 and negative 16 divided by 0. Can you divide by 0? No, you can't. Not a number. So this one is no solution. Okay, so the only time you are going to have a special case is when D is 0. If you got D equals 10 and X was 0 and Y was 5, then it would just be 0, 1/5. It's okay to have zeros for NX and NY. It is not okay to have 0 for D, because then you're going to divide by 0 and that's a problem. So if you have all zeros, then it's infinite solution. If D is 0 and NX or NY is another number other than 0, then you are going to have no solution. Okay, that's Cramer's rule. Again, the benefit of Cramer's rule is that it eliminates any, substitution or elimination with crazy answers like 1929 over 3629. You could solve that system by substitution or elimination if you want to. Keep in mind, you would be working with some really big, ugly fractions, which, of course, I tell you is always okay, but you guys seem to be afraid of them. So this will eliminate the have to use algebraic, solving systems and elimination with big, nasty fractions. All right? It's Longo, and I'm out of here. Have a good one.